most critical thing we think about when it comes to gathering stats. Your maintenance windows are getting shorter and shorter. Maybe you're even gathering statistics every time you load the data. Whatever approach you're taking, it needs to still be fast. So for a 1% sample, 797 seconds, practically 800 seconds. Auto sample size, 1900. So not identical, but certainly not 10 times slower than 1% sample. 100% sample, 18,000 seconds. So a lot longer. Now let's look at the number of distinct values, probably the most important statistic that we gather on the columns within that table. I'm looking at two of the tables. Order key, quite a distinct column, 450 million. Auto sample size, you got it identical to 100% sample because it is a distinct value in the, or a unique value in the table. 1% sample, not so lucky. Okay. NDV of the comment field, which is a lot more repetitive inside the table, 181 billion distinct values is the correct answer. We got 177 billion. But I tell you now, for plan stability, that will get you exactly the same plan as the 100% sample. Look what happened to the 1% sample, though. It is way off on the number of distinct values. So if you're looking to gather statistics efficiently, and you're looking for them to be as accurate as you can possibly get, then I want you to use auto sample size in 11G. At least give it a go. Test it out and see whether or not it works for you in your environment. Over to you, John.
Well, again, I'm completely in agreement with Maria, so no bloodbath again, okay? I'd like to show you a little model of data, because I am going to move on from where Maria was there. I've got here just a simple query against the orders table. It was a model, a rough model of a customer problem. Status can start. We often have status flags. We look at the data that we've got from this particular data set, and as you can see, I've got two very, very popular statuses. The C was for something like complete, and the X was for something like X retail. I can't remember exactly now. But there were two things which said the orders have been completely processed. And then there's generally a scattering of a few other statuses. Okay? So with that particular data set, the interesting queries that are happening every minute, every 30 seconds were these. Find me the things I need to process. Three queries running constantly through the day saying, find me the few things that we have to deal with right now. So let's build a histogram on this data, right? We'll certainly very efficiently be able to get, there are 5 distinct values because of the approximate NDV and also sample size. What do we get with a histogram? Well, on 4 attempts to create a histogram, Oracle got the following. First attempt, it didn't actually notice there were any S's. If you add up these numbers here, you can see that Oracle picked a sample for the histogram of approximately 5,300 rows. Didn't spot the S's. Next attempt, didn't spot the R's or the S's. Next attempt, same again. Finally, after 4 attempts, lucky sample, we got all 3 of the rare values. Now, my client had a slightly worse problem. They were talking about 5 million rows of the popular values and about 10 through to 1,000 rows of the rare values. And about once every 10 days, we'd gather a histogram, and the histogram would say loads of C's, loads of X's, and nothing else. So when the query ran, what does the optimizer do if you ask for a value that's not in the histogram? It says, well, it's there somewhere probably, so let's take the rarest value that's in the histogram and divide by 2. The rarest value, Oracle said, accounts for about 2,500. When you scale that up, you've probably got about 5 million X's, divide by 2, 250 million S's or P's or R's. So every 30 seconds we do a full table scan of the orders table to find the dozen rows or so which is the value you don't want. We run into trouble if we miss some of the important rare values. Auto sample size is great when it comes to 11G and approximate NDV, finding a number of distinct values. We are in trouble if we actually manage to miss all the rare values when we create histograms. So my general guideline for many, many years has been do not just let Oracle gather any old histograms, tell it you don't want histograms. But after it's collected stats, running your own special programs which tell it which column to collect histograms on and sometimes how actually to create them. So auto sample size is great for a number of distinct, but boy, it can be bad news for histograms. values only appear during the working day, and you collect stats at 10 o'clock at night. There is nothing to process at 10 o'clock at night. The histogram says there's nothing to process. The moment there is something to process, the histogram says there's loads of stuff to process because of the way Oracle works. Not only do you have to think carefully about what goes into your histogram, you have to think very, very carefully about when you allow Oracle to create the histogram, if you're going to let Oracle do it at all. So, histograms spoil Maria's suggestion. Switch off histogram collection, think very carefully about how you fake them, about how you gather them, how you create them, what you do about them. Here's faking a histogram, by the way. This is a solution for this client. It's part 2 of 2 first, because this is the interesting bit. Create an array of characters there. There's my list of possible values for this column in alphabetical order. Second array is numbers. There's the list of numbers which represents 10,000 rows of data. There's a few P's, R's and S's. There's a 50-50 split between the C and X's. EPC, endpoint count. There are 5 items in the array. Run up that program, prepare column stats, set column stats. I've just created in a tenth of a second or less a histogram, which is a very good description of my data. I do not want Oracle actually to go and look at the data and waste its time gathering stats, especially at the wrong time of day. Part 1 of this, by the way, is just simply the start of the PL/SQL procedure. There's our declaration of the 2 arrays that we need. There's a few variables we need which account for the number of distinct values, the number of nulls, the column length, and the number of, the density. What should we pretend about the data which doesn't appear in the histogram in certain circumstances? Right? Very short program. Blog item, that's if you need to see my blog to look at a few more details on this one. Okay? 12C, mind you, changes. For histograms where you're going to get a frequency histogram, or one of the new types, which I'll talk about later, 12C, I begin to trust Oracle to collect the histogram. Remember my 4 sets of histogram stats from the 11 to 03 with the auto sample size in place? 12C with auto sample size, if it's going to be a frequency histogram, look at that. Oracle extends the approximate NDV trick to histograms which are frequency histograms. It samples 100% of the data at the same time that it's doing this scan for the approximate NDV. Free of charge, you get a perfect frequency histogram. When I say free, it's marginal on top of the fact that you're calculating NDV. It's basically free of charge. Just make sure you do it at the right time of day. Okay, I will leave that to Maria to carry on.